Hi, this is Kevin. Welcome to my tutorial on Chapter 7 in the Zelle book, Exercises 3 and 4. Let's get started here. So, I believe that Exercises 3 and 4 really fit the same kind of pattern. Okay? And that is, they can both be solved using a multi-way decision using if, else, if, elif, else. I always have a hard time deciding whether I want to call it elif or else if, and I wind up calling it about half and half. I'm going to try elif from now on. Okay, so these are pretty typical things. We have a multi-way decision. It's more than two-way, and a really good way to do that is with if, elif, else. And so we're going to do that here. The example that we're going to do is a classic that I use in programming classes for all kinds of languages. This is there's some kind of a track meet or foot race, and we have ribbons that we need to award for to the people who place in certain places. And we're going to award them based on some scheme. The scheme I have here gives ribbons to the first 8 finishers, and the 9th and higher don't receive any award at all. I kind of copied this from a company that has a website for track meet ribbons. So I don't know how common this is as a scheme, but it was one suggested by a company that makes and sells some of the ribbons. Okay, so here's how we're going to do it. First, I'm going to do this a pretty straightforward way. I'm going to code it. Inline. Okay. And I'm going to show you how to test it in the conventional way. And then I'm going to go on to a second phase where I show you how to extract the logic that does this into a method or a function. Okay. And then how to revise the testing so it's more comprehensive and easy to maintain. Okay. And so that's how we're going to do it. So we're going to put this all into a main. So let's define a main. And I think we could use the text to be a little bigger. Yeah, let's try something like that. So we're going to define a main. Okay. And I'm just going to put a pass into it. You'll recall that pass is the non-operator statement. It says no action at all, just pass on by. And that will get my Python editor to not complain that function's empty. Okay, and you have to remember that we decided that we're going to call the we're going to do the call to main in a slightly different way from now on. And what's that way? Well, I'm just going to go look back at the tutorial that we have from exercise 1. I'm going to copy the code because there's too many fussy characters in it. But what we're going to do is we're going to check if we've been called as the main procedure, which again, this isn't really going to affect the way that you and I typically run these kind of things, but it will help us in the long run if we're going to do things the way that kind of old-timey Python programmers always have. Okay, for right now, it's not going to do anything different than just the call domain did, because we're always going to be running these in the short run as a directly as a script, and we're not going to be importing them in the short run. Okay, that's good. So if we test that, we won't get much, but let's change out that pass for a print. Okay, and how about this? How about this as a polite title for what we're doing? Calculate the award given to a participant at a track meet. Okay, that sounds good. All right. So how are we going to do this? Well, I always like to have a blank print between that and any prompting that we're doing for data. And let's say this. So we want to prompt for some kind of integer that is going to say what place they came in. Okay, that sounds great. Let's say place. Okay, and what we're going to do? Well, we're going to prompt, but we're not going to want to get back anything other than an int. Okay, for instance, we don't want to know that somebody came in third and a half place. Okay, let's say we don't worry about ties right now. And if there are ties, if two people come in second, then we're just going to answer second for both of them. So they'll both get, in this case, red. All right. So we're not going to do that eval, which would allow us to get back a float or an int. We're going to wrap this in an int, which is going to make sure that we get back an integer. And then we're going to do our normal prompting input. And the argument to that is a character string to prompt with. Please enter place as integer. And we're going to put that extra space on the end to get that. And now let's, just for testing, we're going to print place. All right, let's give that a run. Okay, and okay, that seems to be running okay. So let's say second place, 2. Okay, that looks pretty good. All right. So how we're going to translate these? Well, we've said that we're going to do it with an if, elif, else construct. How else could we have done it? Well, we could have done this with a list. In fact, if we didn't have the situation where we had runners, well, we could do it with a list. We could go through and populate the list for first, second, third, fourth, blah, 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 and we could just put the names in. And then we could do, we could retrieve the proper element of the list. We'd have to worry about the fact that the indexes would be one off from the place that a person was finishing, but we could do a little index math and we'd be fine. We'd also have to make sure that we made the list long enough to deal with any particular number of runners and all that kind of stuff. But a more typical way to deal with this is the kind of code that we're going to do. Okay, so let's do that. So we're not going to print the place. Let's say if, okay, place, and again it's equal 1. All right, then let's say award equals blue. Okay. And then we can say elif place equal, and let's just put 2, and we can say award equals red, right? And then let's see, well, how many more of these do we have? Well, we've got all the way through brown. So we've got 1, 2, 3, 4, 5, 6 of these. So what I'm going to do is I'm just going to clone this 6 more times. Okay? So paste 1, 2, 3, 4, 5, 6. All right. And I got some problems there, but we'll back these off. I think we can highlight this whole block of text and then say I want to shift tab it. Yeah, it all came back to the left. And then of course the awards need to be indented, so we'll indent those. So maybe if I had been a little more careful I would have been okay. Okay, so let's fix the numbers. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, that looks good. And of course, what do we have? We need we have blue, so we need red, white, yellow, maroon. Okay, red, white, yellow, maroon. And we've got green, light green, brown. And you might wonder why I have a green and a light green. And that's because I took it off of somebody's actual award scheme on a website. So perhaps it's always like this, or just for this particular company, or just for this particular sport. I don't know. But I stole it. Fair and square. All right. So that takes care of all of the properly placed people. But what about if it's not one of these? Okay, great use for the else. So we'd say else, well, we've got our colon, else, award equals, so if you don't, get 1 through 8, then there's no award earned. So let's say that, no award earned. And everything else seems to be in all caps, so I'm going to put it in all caps. No award earned. Okay, that looks good. All right, so I think this is pretty good logic. We'll go back and check it out before we're done. So let's just come down here and let's print, right? Let's just print award. Let's not be too fancy right now. Okay, and let's give it a run. Okay. So I'm gonna keep my chart up here where I can see it while we're testing. Okay, good. Let's run it again. Okay, make that a little bigger. So first place is blue. Let's look again. Let's run it again. third place, sorry, make it a little bigger. Third place is white. It looks good. Let's look up here. So that seems to be going well. So let's try the ninth place. Okay. So if you come in ninth, no award earned. Okay, that looks good. And then let's try 0, which isn't a reasonable place, but perhaps people who didn't finish get a 0. That's a possibility. And it's pretty robust. It gives us the right answer. Okay. Now, a couple of points to be made about this code. So let's give ourselves a little more room to look at the code as is. Okay. And this would be pretty good. All right. Now, we haven't fully tested it. Okay. Let's, before we talk about how to fully test it, let's talk about whether we're checking for the values in the right order. We've seen in other kinds of code like this that if in fact we're trying to capture a range of values, it's important. Typically we do that with comparisons that are inequalities, not equal, less than or equal, less than, greater than or equal. Okay. And it's important to do it in a particular order because we're picking off cases, okay? And at any place in this LF structure, we want to know that all of the previous cases have already been taken care of. Not so in this kind of approach. In this kind of approach, this is what I would call an exhaustive approach, okay? There's a one-to-one mapping of all of the legitimate values 1 through 8, and then everything else gets its own kind of error value, no award earned. Okay, great. So in that situation, it doesn't really matter what order you check the values in. The only thing that matters is that you check all the individual values before you have an else, which it takes care of the other cases. Okay, so we could have said, 3, 5, 2, 1, 7, 8, 6. Okay, the problem is that's bad documentation. So the coding would have worked just fine, but as documentation and maintainable code, it's crap. Okay, so we don't want crap. So I think we've done this pretty well here. So I like the way we've coded it. I like the order that it's in. The one thing I don't really like is it's not particularly easy to test. Okay? Well, why isn't it easy to test? Well, the kind of test I have right now is an inspection test. Okay? I have to, I get prompted for input. Okay? And then I put the input in. I get a result back. It's printed. So I have to read it. So I have to type input in, I have to read it, and then I have to judge, did I get the right result? Okay? Now, what I'm going to do is I'm going to do a kind of a test that I showed you guys in a previous example. And it kind of mimics the way we do testing with these testing frameworks without having to really introduce them. Okay. So how could we do this? Well, the first thing that you need to do is you need to take the code that's going to be tested and you need to extract it into a method. Well, that's not too hard. We've done that before. The code that needs to go into the method is right here. Okay? It's the decision logic. What's the input? Well, place is the input. What's the output? Well, award is the output. Okay? So let's right-click, say refactor, extract method, reminding ourselves that what we're really extracting here is a function because this isn't in class. And we say, what's the method name? And let's call it determine award. So what the parameters? What's the input place? What's the output variable? Award. Perfect. Click on OK. All right. Now that looks good. All right. Now one of the things I really like is that the main, let's say we had a main that was about more than simply testing this function. Well, then it wouldn't be cluttered up with 15 lines of code that were all about one decision to come up with to translate a place number into an award description. Okay, and so we don't really want to do that. So we don't want to use all those lines up here, so we extract it into a method. I think that's good. Now I'm going to say, you know, maybe this kind of testing isn't what we want. Okay, and a testing scheme that works really well is one in which we do two things. One is that we decide what are the test cases. Okay, so test cases that we've done in the past have been based upon boundary value testing. Okay, that works really well when you have decisions in your code that are going to give one result if it's 0 or less, another result if it's 1 or more. You're trying to explore the boundaries and make sure you get the right treatment. In this case, we've only got one boundary. Well, we've really got two. We've got less than 1 as a boundary, okay, and greater than 8 as a boundary. So we've got some boundary value testing, but what about the ones in between? Well, they're all treated individually. So to do this, we would have to test 0 or less individually, 1, 2, 3, 4, 5, 6, 7, 8, and 9 or more. So that's 8 plus 9. We have 10 test cases. Okay, so this is pretty intensive to test. So let's do this a different way. Okay, let's get rid of all the prompting. Let's not have this be a testing that we do by hand. Instead, we're going to start to evolve ourselves toward more automated testing. Okay. Okay. So, how do we find out what the award is? Well, the award is a function of the place. Okay. So, if we let's do the first case. Let's do 1. Let's do the actual values first. So if we determine award 1, we should get back the string blue. Okay. So let's do the following thing. Let's print. Okay. And let's say if we call determine award with the argument 1, we're going to expect the result that comes back, the string, to be equal to blue. Okay. So if in fact that's a successful test, that comparison is going to yield a Boolean value true. And you might recall that I showed you this a couple of examples ago. So let's give this a true, a chance. I'm expecting this to come back true. All right, let's give it a run. Run. True. That's a successful test. Okay. If in fact my code, if in fact I had put something else here, I had either gotten things wrong, you know, either the code was wrong or the test was wrong, then I would run the test and I'd get a failure. I'd get false. There's false. Okay, so let's back this up. Blue. Okay. Now I'm thinking I need 8 of these. Okay, so I have a blank line here I don't need, so I'm going to get rid of that. I need 8 different values for the direct value cases. So I'm just going to add 7 more. 1, 2, 3, 4, 5, 6, 7. Okay, and now I'm going to try to get all these in the right in our window at the same time. So I want to do these in order. So I'm just over typing these. 3, 4, 5, 6, 7, and 8. Those are all the direct values that get awards. And sometimes what I like to do here is just get rid of the wrong answers first. I can more easily see what I've done and what I haven't. Now this could be just a compulsiveness on my part. You could never really tell. Your mileage is definitely going to vary here. Okay, so let's get them in order. So the second one is red. I double click on that. Control C. Control V. Actually on my Mac it's a command. Third one is white. Command C. Command V. Next one is yellow. Next one is maroon. Next one is green. Next one is light green. Let me highlight that by hand. Copy that. And the last one is brown. Okay, so let's find brown. Okay, that looks good. Okay. Very nice. That makes sense. So that's saved. So let's run a test. And they all came back true. All right, that looks good. So have we covered all the test cases? No, we haven't. Okay. What if it's 0 or less? Okay, let's copy another one up front. I like to keep these in order. Again, it's good documentation for when you're doing your maintenance. So let's say if we have a 0 as the place, we're expecting to get no award earned. Let's just add that on and see if it works. See if that comes back. All right, so let's give it a test. And again, we've got all trues. Very good. And then we've got one more down here. We have 9 or more. So let's put 1 down here. And indent it a little better. Okay. And give it a 9. And say that should be no award earned as well. Now, I've got to tell you, well, first of all, let's make sure that works. See if we can discover any errors there. Nope, all coming back true. So that looks pretty good to me. Okay, do I need test cases on the low side of 0? Do I need a -1, a -10? Do I need on the high side of 9, 15, 20? Well, there's a lot of arguments kind of either way. Okay, the question is whether you are you're the programmer yourself. Here you are the programmer. So what we're doing is clearly called unit testing. And it's usually testing with a knowledge about the vulnerabilities of your own code. Okay? And we happen to know that because the boundary is between 1 and 0, that testing just on the other side of the boundary is all we need to do. And we happen to know that because the boundary is between 8 and 9, testing at 9, that's all we need to do. We could test at 9,000, 900,000, it should all say the same thing. Okay? So, from the school that I come from, which I would claim is the right thinking school, these are all the tests that we need, and if we run them, we're going to get a bunch of truths. Okay? Now, does everybody test with this exact style? No, they don't. Okay? Is this a good style? Yeah, this is a good style. One of the things we're going to learn is that there are testing frameworks that are even more convenient and repeatable than this, but we're not at testing frameworks yet, so this is, I think, a good kind of a middle ground. The other kind of testing that we were doing is it's highly interactive. You have to remember to provide the right values every time, so you could miss a test case. And then it's highly dependent on good inspection. And given human nature is to see what we expect, and you'll know that from how well you proofread your typewritten documents. This turns out to be a much more effective way to test the method. Okay, so this is an ideal way to test the method just like this. Okay, so that's it. We've got it working. And I think we've done a good job of testing it, and it's tested in a way that's going to serve us well over the life of this code. Okay? So, having said that, I'm going to say bye. Bye for now.